So by the end of this is how your controller should look like. You'll be able to walk left and right as well as shoot, and all of your animations should look perfectly and they will look basically natural. So yeah, here we go. Okay, so to start us off, we have this really great scene. We have a 3D component with basically a 2D collider. So on Mixamo, we have this really great character, and as you can clearly see in the animation, it looks really good. Okay, but seriously, now let's download the object with FBX for Unity and T-pose. And back in Unity, let's create a new folder, call it character. Open it up, and we can just drag and drop our model to Unity. Okay, now let's drag it into our scene. There we go. Now let me just position, rotation and scale this up. There we go. Now let me just extract the materials and the textures. And there we go. Now we have a character along with all its textures and materials. So yeah, now let's head back to Mixamo, and we're gonna need some animation. So first of all, pistol idle. This animation looks good, so we can just have that. There we go. And now we can just download this thing. So this time we're gonna do without screen and just download this, and we can just drag and drop this into Unity. Open it up, select the animation and just Ctrl D to duplicate it. Turn on loop time for this, and we can just delete our FBX. There we go. Let me just unpack this, and now we can just drag and drop our animation. And we can go to the animation tab, and there we go. Now we have our animation inside Unity. Okay, now next up we're gonna need two more animations, which are of course pistol walk and walk backward. So we can just have that in place, and we can just go ahead and download this without skin again, and we can download the walk backward as well. In place, download without skin, and just click on download. And we can just drag and drop these both into Unity. Open them up, select the animations, Ctrl D to duplicate, remove the FBX, and we can again turn on loop time for both of them. Perfect. Now we can also just simply drag and drop the rest of the animations onto our character. There we go. Now first of all, we're gonna need to install a package. Let's go to package manager and make sure you're in the Unity registry, and we can just type here animation. There we go. We have the animation rigging, and just simply click on install. Now it's time to do some programming, so let's create a new mono behavior script, call it move, and we can open this up in Visual Studio. Here we have the script, it's in the description, and let me explain. So we are just getting a horizontal keyboard input and storing that in a float, and simply changing the character's rigid body's linear velocity according to that float. Then if we are moving towards left of the screen and we are facing right, then we simply flip our character, and the vice versa goes for the other side. And now in order to flip the character, we are currently just rotating. We are simply just rotating the character. So yeah, there's that. Let's head back to Unity. First of all, let's add the components, physics 2D. We're gonna need a collider first of all, and as you can see, it doesn't actually collides with the box object, which is of course will happen when we are working in 3D space for 2D game. So we can create a child collider, and we can just rotate it so it faces the correct way. There we go. Now we just need to add rigid body component to our character, so let's do that. Add component, physics 2D, and we can just add rigid body. There we go. And now let's add our script to our character. We can just drag and drop this onto our character, drag rigid body into our script, and as you can see, there are some issues. So the primary issue, so there is nothing wrong with the script, actually it's working perfectly fine. The issue is actually with with rotation. So as you can see, for 90 degrees it's currently facing right, and minus 90 will be facing left, and here it's actually 0 and 180. So we need to change that to 90 degrees here, and minus 90 for the left side, as simple as that. Back into Unity, and now if I go towards right, it falls, of course. Let's go to constraints and freeze rotation, and let's try that again. And this time it actually works. We press right and left, it goes towards that, and it actually flips correctly. Excellent. Now it's time to add some animation. Let's create an animator variable here. There we go. And we can actually just use this float that we used for animations, because well, we're gonna use a blend tree. Don't worry, it's pretty simple. So we can just say anim.setFloat speed as, and we are not gonna use the math.absolute here. The reason why, well, we are gonna need to, let's just say, let's not use it. We're gonna see that later. Let's head over to our animator, and we're actually just gonna create a new blend tree. Let's call it movement, and let's change the parameter. Let's head over to the parameters, and remember the name of the parameter needs to be the same here. So we can just copy it and paste in here, and we can add the motions, all three motions: the idle, walk left, and walk right, which is, well, walk, idle, walk, and walk backward. There we go. And we can change the threshold. There we go. And now if we change the speed variable, you can see in the blend tree animations. Now we can just drag the animator onto its position. There we go. Oh, before playing, make sure that your blend tree is the layer default. And now we can just play. If we move towards right, you can see that we actually moves, but if we move towards left, it doesn't really work. Let's just change that. So since we are flipping, we actually need to flip the main value as well. So we can just create a simple float called flip, and we can just simply say that it's okay. So what it does here is that if we are facing right, the float flip will be 1, and if we are not facing right, then it will be -1. And now we can just multiply that by flip. There we go. It's a better way to understand how this works. That's why I wasn't just like adding the math.absolute. There we go. Now if we play, you can see we walk in the right, it goes perfectly, as well as in the left direction. Excellent. But now, well, we are not actually using the walk backward animation, so don't worry, we're gonna use that later. Now we're gonna go into actually using the animation rigging package. So let's go to our bones of our character, go to here, and bone render setup. This allows us to, well, see all the bones that our character has, and we can just decrease the slider so that we can just visualize our bones better. And now remember, where your animator component is, select that and just add the rig setup to that. There we go. Now we have a rig setup, and we can add child components to this to, well, let's just say, use it. So what are we gonna do? We're gonna just simply right click and create a new child to this, and we can just call it as aim IK. It's not inverse kinematics, but I just like to call it that. We can go to animation rigging and call it, and just add the multi-aim constraint. What this constraint does is basically it allows us to change a bone's rotation so that it faces something. But first we're gonna need a pistol so that we know what way we're facing. So I got this pistol model from Sketchfab, and we can just make it the child of our hand. And let me just position, rotation, and scale it so it's like our character is holding our gun perfectly. Okay, now let's create a new cube, and we can just call it as target. This is going to be the thing that our character will keep on targeting. So there we go. Now we have that, and we can just move this around a little bit to here so that our gun actually targets the correct thing. Okay, now all we need to do now, let's first of all make this so that we can easily visualize our target here. So I can just create a simple material here, call it target material, and just drag and drop this to our target, and I can make it a lot more emissive so we can easily see it. There we go. Now in our aim IK you can see a source object and just drag and drop the target here. And now if we click on play, you can see that when we move our target, something happens. It does rotate, but it's not facing the correct axes. So we can actually see in here that the aim axis in here is actually y axis, and the top axis for the gun is actually negative x. You can see in here, right? So in our rig, in our IK rig, you can see it's not like correctly for it is, so we need to change this to y and negative x. It sounds a little bit complicated, but it's actually really simple once you get used to it. And there we go. Now our gun is facing our target perfectly, and we can actually just move this target and you can see the gun follows. So that works perfectly, but currently it's not looking like natural, because well, when we move our gun, our entire body should also move, right? So we can just go in here, go to our rig, create another child, and this time we can just call it as, again it doesn't matter, but you can call it whatever, but make sure that it's above our aim IK. Just make sure that is there. We can add another multi-aim constraint, and we can just use the spine this time, the spine bone here, so that our entire body moves along with our aim. So we can just drag and drop the spine as the constraint object this time, and the target as our source object. And as you can see, for spine it's actually perfectly set up. The z-axis is the aim and the y-axis is the top, and the same goes for here. The z-axis is aim and y-axis is top, and we can just click on play. But before playing, we can actually just decrease the weight in here to 0.7 so it doesn't like exactly rotate. And there we go. Now if we move the target, you can see it looks a lot more natural. The entire body actually moves along with our aim, and yeah, there we go. Now all we want for our aim, the target aim, is to, well, basically move the target to wherever our mouse is, right? So let's create a new method called aim, and we can just create a new method here. There we go. And now we can just get a transform component in here, call it aim point, and now we can just add this code. Alright, and here's our code. We're just first of all we take the mouse position from the world and save it as a vector3 mouse screen position, and then we make sure that the mouse screen position's z value remains our own float, which is the depth from camera float. Yes, we define that above, and then we simply convert that to a world position, because again, remember, we take the mouse position from the screen and then we convert that to world position, and then we simply just set our transform variable as that position. It's again, it sounds complicated, but it's really simple. Now let's head back to Unity, and we can just drag and drop our aim point in here, and remember to change the depth from camera float as well, and we can just play here. And as you can see, our aim does work, but we need to change the depth from camera to like 10, and yeah, there we go. Now as you can see in here, our target actually moves to the position of our mouse, but now again you will see an issue in here, that when we are facing the camera, like when we are facing the target, it works well, but when we are not facing the target, it's a bit weird in here. Although since the animations are really good, you can't really see much of the issue in here, but but we basically want our character to flip when we are not facing our character, basically. So how do we do that? Let's head back to script. Now again, to change this part, you can actually add a simple boolean here, that whether you're actually aiming or not, if you don't have a direct aim mode. But for now we are just gonna comment this part out. Okay, so now no, we are not gonna remove the flip function. So how do we exactly do that? It's actually really easy. So where we use the aim functionality, we can just add this condition here. So it's basically the same as inputting from keyboard, but it's just now the position on x-axis. So if our target's position on x-axis is towards left of our character's position and we are facing right, we simply flip our character, and the vice versa towards the right side. Back in Unity, I changed the depth from camera a little bit more, and we can just click on play here. And as you can see, when we go towards left of our character flips. So yeah, that's working really well now. And as you can actually see, our back movement, our pistol back movement also starts working here. So we are currently just using local position, but if we want, we can actually just change the scale of our character on the z-axis if to like exactly change it so that the way it's facing right is the exact way it's facing left. But currently we can just rotate. We can just, instead of using transform.local rotation, you can just use transform.local scaling here. And currently our like back movement is actually a little bit slow compared to our like front movement, so we can just go to animator, open our blend tree, select our blend tree, and increase the speed in here. There we go. Yeah, that works well. We can just play and see if it works well. Yeah, that looks good. Now to add some shooting to our game, we can add another script in here, call it pistol shoot. Open it up in Studio, and it's a really simple script compared to the script that we just made. We can just create a game object here, call it shot, a transform here from the position we are supposed to call the shot, and in update we can just simply say that if we are pushing our mouse button, we can shoot, and we can actually just instantiate our bullet at our muzzle position, and we can just get it as a game object, and we can just simply add like velocity or some force to the rigid body of our bullet. So we can just get its component, and then we can just change its rigid body dot linear velocity to some speed, and we can define the speed in here, and we can just multiply that in here, change the rigid body dot linear velocity, and we don't want it on the muzzle positions dot right direction. We actually want it to go towards the bullet's own forward direction. So we can just say in here that geo dot transform dot forward, so it goes towards the forward direction of our bullet itself. And we can just save this and head back to Unity. Let's create a bullet. So a 2D object, a 3D object, a spear, and we can just call it bullet or shot. We can remove the sphere collider from it because again we are using 2D physics, so a circle collider will work great. And simply scale this down, and now we can add a new material to our shot. There we go. And just for visual effects, we can add a trail to our bullet, just because, well, why not? And add a new material to that as well. Just modify the components in here, and this is how our trail looks. Nothing fancy here, and we can just, and as you can see, when we move our bullet, it leaves a nice little trail. Now we can just add a new component, rigid body, to our bullet. Let's add pistol shoot to our character, and we can just first of all make a transform of the muzzle point where our bullet will spawn, and we can just make that as here, as this. Drag and drop that, and let's create a prefab of our shot and delete it from our scene. And we can just drag and drop our shot onto our pistol shoot script. And yeah, now we can just click on play to see how it works. If we shoot, you can see it basically just falls down. So we have to change a few things in here. First of all, let's head back to shot and change the gravity scale to something like 0.01, because I don't want much like bullet fall. And we can also increase the muzzle velocity. Let's play again, and yeah, now it looks much better. Now you can of course add a lot more stuff to this, but for now I'm just gonna keep it as is. Now I'm gonna head back to Google, and I found this pretty neat target UI and we can just drag and drop this image to our target, reset the transforms, and make sure to increase the order and layer of our target. And so yeah, now we have a good target to aim at. So yeah, I guess that would actually be just about it for now. I hope I helped you a little bit. So if I did, make sure to you know what to do if I did. Yeah, that would be just about it. That's all for now. See ya, peace out.